Good morning, everyone. Thank you for being here today. I'm excited to introduce you to our Shielded Metal Arc Welding, or SMAW, welder training program. On this first slide, you'll see the title of our presentation, and I want to give you a quick idea of what we'll be covering. We'll explore the fundamentals of SMAW welding, discuss the training process, and highlight the skills you can expect to develop. So, let's get started and see what's in store for you in this exciting training journey. Now, let's take a quick look at what we'll be covering in today's session. We'll start with an introduction to SMAW, or Shielded Metal Arc Welding, to understand its basics and significance. Then, we'll move on to an overview of the equipment involved, so you know what tools you'll need and how they work together. Safety protocols are next, because safety always comes first when working with welding equipment. We'll then dive into the actual welding process, breaking down each step to ensure you understand the technique. Following that, we'll discuss electrode selection, which is crucial for achieving strong, reliable welds. We'll also explore various welding techniques, highlighting tips to improve your skills. After that, we'll look at common defects you might encounter and how to troubleshoot them effectively. To wrap things up, we'll preview a practical demonstration so you can see everything in action. And of course, there will be time for questions, so feel free to ask anything that comes to mind. This agenda sets the foundation for a comprehensive understanding of SMAW, helping you become more confident and proficient in your welding skills. Now, let's take a closer look at SMAW, which stands for Shielded Metal Arc Welding. This is a manual arc welding process that relies on a consumable electrode. What makes it unique is that the electrode isn't just a filler material, it's coated in flux. This flux coating plays a crucial role in protecting the weld from contamination and helps create a stable arc during welding. SMAW is incredibly versatile and widely used, especially in fields like construction, pipeline work, and maintenance. Its portability and simplicity make it ideal for outdoor and on-site welding, where you might not have access to complex equipment. When performing SMAW, the process involves melting both the electrode and the base metal. As the electrode melts, it deposits filler metal into the weld pool, forming a strong joint. The flux coating also generates a shielding gas and slag that protect the molten weld from oxidation and impurities. Overall, SMAW's effectiveness lies in its straightforward approach, manual control, portability, and the ability to produce durable welds, making it a fundamental technique in many industrial applications. As we go through this presentation, keep in mind how these core aspects fit into the bigger picture of welding technology and practice. Let's take a closer look at the equipment you'll be using for welding. First up is the welding machine itself. It can be either a transformer or an inverter, and each has its own advantages. The transformer is more traditional and robust, while the inverter offers greater control and efficiency. Understanding these differences helps you choose the right machine for your specific needs. Next, we have the electrode holder. This is the tool you'll use to hold the electrode securely while welding. It's important because it ensures a good electrical connection and safety during the process. Alongside that, there's the ground clamp, which is essential for completing the electrical circuit. Proper grounding is critical for both safety and the quality of your weld. Moving on, you'll need electrodes. These are the consumable parts that create the weld. Different electrodes are suited for different materials and welding conditions, so selecting the right one is key to a successful weld. Finally, safety is paramount. Personal protective equipment, or PPE, includes a welding helmet to protect your eyes and face from sparks and UV radiation, gloves to shield your hands from heat and sparks, an apron to protect your body, and goggles to safeguard your eyes when not wearing the helmet. Remember, no matter how experienced you are, safety gear is non-negotiable. All of these components work together to ensure a safe, efficient, and high-quality welding process, tying back to our overall theme of mastering proper welding techniques. Now let's talk about some essential safety protocols to keep in mind. First and foremost, wearing the proper personal protective equipment, or PPE, is absolutely mandatory. This means gloves, safety glasses, and any other gear required for the specific task. It might seem simple, but it's crucial for your safety. Next, ensuring adequate ventilation is key. Good airflow helps dissipate fumes and prevents the buildup of potentially hazardous gases. Never underestimate how important proper ventilation is in maintaining a safe workspace. Another important point is to avoid moisture around electrical equipment. Water or damp conditions increase the risk of electric shock, which can be deadly. So, always keep your work area dry and be mindful of any spills or humidity. Also, a quick but vital reminder: never look directly at the arc when working with electrical or welding equipment. The intense light can cause serious eye damage, so always use appropriate safety shields or viewing screens. Moving on, fire safety measures are critical. Make sure fire extinguishers are accessible, and be familiar with how to use them if needed. Keep flammable materials away from hot work areas, and always follow proper procedures to prevent fires. By following these protocols, we not only protect ourselves, but also create a safer environment for everyone involved. Safety isn't just a set of rules, it's a mindset that supports our overall goal of safe and efficient work. Now, let's take a closer look at the SMAW process, which is fundamental to understanding how this welding method works. First, you need to strike the arc, and there are a couple of ways to do this. You can use the scratch method, where you lightly scratch the electrode against the workpiece, or you can tap it gently to establish the arc. The key here is to make sure the arc starts smoothly without creating too much spatter or interruptions. Once the arc is established, maintaining the proper arc length is crucial. This means keeping the electrode at just the right distance from the workpiece. Too close, and you risk sticking the electrode; too far away, and the arc can become unstable. As the arc burns, the electrode melts, forming a weld pool that fuses the base metals together. You'll also notice slag forming on top of the weld. This slag is essentially a layer of melted flux that solidifies as the weld cools, serving an important purpose. It protects the molten weld from contamination and oxidation by atmospheric gases. Once the slag solidifies, it acts as a protective barrier, ensuring the weld cools properly and maintains its strength and integrity. Understanding these steps highlights how each part of the SMAW process plays a vital role in producing a high-quality weld, and it ties directly into our overall focus on effective welding techniques. Now, let's talk about electrode selection, which is a crucial step in ensuring a strong and reliable weld. When choosing the right electrode, we need to consider a few key factors: the type of base metal we're working with, the weld position, the polarity, and the required strength of the weld. Each of these elements influences which electrode will perform best. Commonly used electrodes include E6010, E6013, and E7018. Each of these has distinctive characteristics that make them suitable for different applications. For example, E6010 is known for deep penetration and is great for welding in all positions, especially on dirty or rusty metals. E6013, on the other hand, is a versatile electrode that offers easier handling and produces a smoother weld, making it ideal for general-purpose welding. Then, there's E7018, which is a high-strength electrode often used for structural welds where strength and ductility are critical. Understanding these differences helps us select the appropriate electrode for the job at hand. Remember, the right choice not only ensures the integrity of the weld, but also improves efficiency and safety in the welding process. So, always consider the specific requirements of your project and match them with the characteristics of the electrode you're using. Now, let's talk about some essential welding techniques to ensure quality results. First, maintaining the correct arc length is crucial. Ideally, you want about 2.5 millimeters, just enough to create a stable arc without excessive spatter or porosity. Keeping this consistent helps produce a smooth, even weld bead. Next, the travel angle plays a vital role. A dragging angle of around 10 to 15 degrees is recommended, which means tilting the torch slightly in the direction of travel. This helps control heat input and improves penetration. It's also important to maintain a steady travel speed. Moving too fast can lead to weak welds, while going too slow may cause excessive heat buildup. Finding that right pace ensures good fusion and prevents defects. Lastly, depending on the weld type or position, you might need to use a string or bead, just a straight, steady movement, or a weaving pattern to fill larger gaps or achieve a wider weld. Adapting your technique like this can make a big difference in weld quality. Overall, mastering these techniques forms the foundation for strong, reliable welds, and they tie back to our broader goal of ensuring safety and strength in our fabrication work. Now, let's talk about some common defects you might encounter during welding and how to troubleshoot them. First up is porosity, which appears as tiny holes or cavities in the weld. This usually happens when gas gets trapped inside the weld pool. To prevent this, it's important to check the cleanliness of your surface and ensure your electrode is in good condition. Next, we have slag inclusion, which is when slag gets trapped in the weld. This often results from improper cleaning between passes, so make sure you're thoroughly cleaning the weld area to avoid this issue. Moving on to undercut, which shows up as a groove or crack at the edge of the weld. This can happen if you're using excessive current or moving too fast. Adjusting your welding parameters can make a big difference here. Lastly, spatter, which is those small molten droplets flying out of the weld. Spatter is usually caused by an arc that's too long or incorrect polarity settings, so keeping your arc length consistent and verifying your polarity can help reduce this problem. By understanding these common issues and their causes, we can improve our weld quality and achieve more reliable results. Now, let's take a look at what you can expect in the practical demo preview. We'll get hands-on with the SMAW setup, which means you'll see the equipment in action and understand how to prepare and operate it properly. This is the core of learning welding, actually doing it. Next, we'll move into bead placement exercises. These exercises are crucial because they help you develop steady control and precision, which are key to producing strong, quality welds. Finally, we'll cover welding different joint types, specifically butt joints, lap joints, and T-joints. Understanding how to weld each of these correctly is essential, as each has its own challenges and best practices. Throughout this demo, the goal is to connect theory with practice, so you can see firsthand how the concepts we've discussed come to life in real-world welding scenarios. This practical experience will build your confidence and competence as you advance in your welding skills. Now, as we come to slide 11, I want to open the floor for some questions or discussion. Let's take a moment to reflect on your experiences. What challenges have you faced with SMAW? Whether it's issues with technique, safety concerns, or equipment setup, your insights can really help us learn from each other. Feel free to ask for clarification on any points, or if you're unsure about a particular aspect of the welding process, now's a great time to get those questions answered. Remember, understanding these challenges and techniques is key to becoming more confident and competent in SMAW. So I encourage everyone to share their thoughts or doubts. No question is too small. This discussion not only reinforces what we've learned, but also helps us connect the dots to real-world applications. Let's make this a productive and engaging exchange. Thank you so much for your attention today. I truly appreciate your engagement and commitment to welding safety and best practices. If you have any questions or need further information, please don't hesitate to reach out to the training coordinator. You'll find their contact details provided. We're also going to share a QR code or a link to the training materials so you can easily access all the resources and review the content at your convenience. Remember, staying safe and welding smart are the key takeaways from this presentation. Prioritize safety at all times and always follow proper procedures to protect yourself and those around you. Thanks again for your time, and I wish you safe and successful welding in all your projects.